This is MEI Statistics Minor, Bivariate Data 1, Scatter Diagrams, 1.2, Scatter Diagrams. The most common visualization for bivariate data is a scatter diagram. Each point, or a cross when we're plotting it by hand, on the scatter diagram represents a single statistical unit. What do we mean by that? Well, whatever it is that's pairing the data. So for instance, a person, a country, a company, an animal. Each axis is a scale representing one of the variables. Now, if one of the variables is independent, this should always be plotted on the horizontal axis. One of the examples from the last video was when a horticulturist was investigating the yield of tomato plants when different levels of fertilizer were used. We decided the level of fertilizer was controlled by the horticulturist, so it is an independent variable. So the level of fertilizer must go on the horizontal axis there. The yield is a dependent variable, so it goes on the vertical axis. And then we plot all our points accordingly. When that data is random or non-random, we tend to find that the data points are in distinct vertical lines. Because this level of fertilizer is being controlled, it tends to be done in multiples of something or in some well-defined levels. If both variables are random variables, so we have random on random, then the choice of axis is less clear. But it may be that one more naturally seems as a function of the other, and that generally determines which variable is plotted on which axis. So for example, an ice cream seller records the average temperature along with the total sales for each day in August 2017. It is random on random because neither variable is being controlled, but we naturally assume that the temperature is influencing the ice cream sales and not the other way round. So we think of the ice cream sales as a function of the temperature. So we put the temperature along the horizontal axis and we put ice cream sales along the vertical axis. Generally, for random on random data, there will be no distinct vertical lines. Scatter diagram will appear as a data cloud, assuming of course that the data is continuous. If we have discrete data, then there may well be lines, either vertical or horizontal. So example 3 is for each of the following contexts, which variable would you plot on the horizontal axis? Another example from the last video. We know the data is random on random, as neither variable is controlled, but we would expect the distance from the sea to affect the number of crabs and not vice versa. So we would put the distance from the sea on the horizontal axis and number of crabs on the vertical. A sample of Year 13 students are taken and each student's height and weight is recorded. It is of course random on random, neither variable is controlled. But intuitively we might think about this and think we cannot control our own height, but we can control our weight. So we probably would put height on the horizontal axis and weight on the vertical axis. A sample of Year 13 students are taken and each student's hand span and foot length is recorded. I would consider these not to be functions of each other at all. I would consider them more likely to be a function of a third variable. In this case, I'd say it's not that important which variable goes on the horizontal axis, but I personally would default to the first variable listed going along the horizontal and the second going along the vertical. In the next video, we're going to be using and interpreting scatter diagrams.